Hello, this is Camille Fairborn from Michigan State University, and I'd like to welcome you to today's Cause Teaching and Learning webinar. We're pleased to have as our presenter today Dr. Lisa Green, who is an Associate Professor of Mathematics at Middle Tennessee State University, and she is the Interim Chair of the Department of Mathematical Sciences there for at least a little while longer. For today's webinar, she will give a presentation entitled A Course Community for a Culture Change. The way the webinars work is that all listeners are muted during the webinar. You can ask questions at any time by typing them into the questions box, and we'll be sure to ask those questions towards the end and give the presenter a chance to respond. You can also use the chat box if you're having any technical questions. So at this point, I'll turn things over to Dr. Green. Lisa, go ahead.
Hi, thank you everybody for attending this webinar. I'm really excited to get the opportunity to tell you about what we did to change the teaching of introductory statistics here at Middle Tennessee State University. So I'm going to be discussing work that I did jointly with Dr. Ginger Rowell, Dr. Scott McDaniel, Dr. Nancy McCormick, and Dr. Jeremy Strayer, who are all here at Middle Tennessee State. So our challenge for this project was we wanted to spread active learning to all the teachers and students in a course, taking the backgrounds of the teachers into consideration. We have a lot of evidence that says that active learning is an effective way to teach. And learning to teach using active learning is difficult enough when it's just you, but when you are trying to get the entire group of teachers who are teaching a course to do it, it becomes that much more difficult. So introductory statistics is often taught by non-statisticians, typically by mathematicians. And of course, mathematicians think differently than statisticians do. And so you've got people who have been trained to think one way being asked to teach a class that is teaching a different way of thinking. In our university, this course, Applied Statistics, is taught by two different departments. The math department technically owns the course. The math department chooses the textbook and writes the common final exam. But there's a prescribed version of the course that is taught through the University Studies Department. And any student with an ACT below 19 must take the prescribed version of the course. Those students meet a little bit more frequently, and they get a little bit more attention from their teachers, but otherwise they learn the same material and take the same common final at the end of the semester. So because we've got two different departments teaching this class, a lot of different types of students, and also different teachers, we want to make the course a little bit more uniform. So if you think about the different kinds of teachers that could be teaching this course, ideally we'd have people with a PhD in statistics teaching the class. That is ideal, but it doesn't happen all that often because of the departments that are teaching this class. We do have a couple of statistics educators that teach this class now and then, but not frequently. Most often, we have people who have a master's in mathematics teaching the class, and often we also get graduate students who are in the statistics program. So if you think about the people with the master's in mathematics, they have a lot of teaching experience, but they don't have a lot of statistics experience. And if you think about the statistics graduate students, they have a lot of statistics experience, but not a lot of teaching experience. So you get these different kinds of people teaching this class. So that leads us to think, what do you need to know in order to teach statistics? And there are three different realms of knowledge that are necessary to teach this class. First is the statistical knowledge. You need to know the content of the class that you're teaching. You need to understand the process of getting data, organizing it, displaying it, analyzing it, and using it for inference. You need to have pedagogical knowledge. You need to know how to get the people in your classroom paying attention to the right thing at the right time. You need to know how to assess people, how to ask the right kinds of questions to get those people to be thinking about what you want them to be thinking about. And finally, you have this strange hybrid knowledge that, if we were talking in general, would be called pedagogical content knowledge, but because we're talking about statistics, we call it statistical knowledge for teaching. And this is the knowledge of which concepts people have particular difficulty with in the course, where students are going to have misconceptions, what you need to understand first in order to understand this other concept, and the ability to do a little bit of categorizing. If you've got 8 questions that have come up, which of the questions are the most important to address right then? The statistical knowledge for teaching is kind of difficult, and it rests very much on the other 2 types of knowledge. You have to already have statistical knowledge and pedagogical knowledge before you can really get into the statistical knowledge for teaching. So if I'm thinking about changing for just myself, I can do some reading, or I can watch videos or something like that and change my own class. But if I want institution-wide change that several different people in the institution are implementing at the same time and that will stick around, I really need to look into what people have learned about changing institutions. And the classic paper on institution-wide change is Lewin in 1947, and he brought up this 3-step process where the first step is before the change happens. It's unfreezing. This is where you're getting everybody to agree that a change is necessary and agree what the change should look like before any change actually happens. The second step is where the change happens. This is the step that we usually focus all of our energy on. And then the third step is refreezing, that is making the change that has happened stick so that in the years to come, this change is going to actually still be in effect. So in our project, if we look at the 3 different steps, the first being unfreezing, we created a faculty course community model. All of the faculty that were teaching this class in a particular semester were invited to participate in a course community that met every 2 weeks during the fall semester and then every 2 weeks during the spring semester. The purpose of the course community was to eventually implement the change to active learning. We were not able to implement the change to active learning in the fall semester, partly just due to the fact that we couldn't get the booklets printed and that sort of thing on time, and we were still testing these different lessons. But it turned out to be a good thing that we didn't start in the fall, because that gave us the fall where everybody teaching the course was meeting on a regular basis, but they weren't trying to implement the new teaching style yet. This allowed us to talk about planning as a group rather than individually, start communicating with each other, build each other's knowledge, and use the data that we got from the course as a whole to make decisions about what was going to happen. So planning as a group. I'm sure everybody here knows that there are way more topics in applied statistics than there is time to teach applied statistics. And that means that you're going to have to decide which topics are the most important and get covered in the most detail, and which topics kind of get glossed over. Planning as a group allowed us to make those decisions as a group and required each of us to justify why we were spending 2 weeks on this topic, but only 1 day on that topic. And it allowed us to be a lot more clear as to what exactly we wanted our students to know at the end of the semester. We did find out that it's important to have a consistent course calendar. Partly this was because our course community meetings often devolved into, I'm at this topic. You're ahead of me, I'm behind by 2 weeks, that kind of thing. Where if we had a course calendar that we were all following, then we could talk more about what the particular topic was and what problems our students were having and that sort of thing. And finally, it was important that we all addressed these ideas at similar difficulty levels. This is an intro class, and we had some people who were being very particular about getting things exactly right and making it a much more difficult class, and other people were not doing that. So it became important that we agreed on exactly how difficult we should aim the course. Because we have 2 different departments that teach this class, we had faculty that had never actually met each other before this project. So part of the purpose of the course community meetings is just to build the friendships between the different faculty members, and then the different faculty members could share their ideas of how to improve the course and how to address student issues and that sort of thing. Part of this was, there were snacks at these meetings. People always come to meetings if there are snacks. We wanted all of the faculty to be treated as respected colleagues. Because there are 2 departments and one department owns the course and the other department doesn't, there was the risk that some of the faculty would be treated as second class, and we didn't want that to happen. They had a lot of experience to give us about what their students could handle and what their students would have difficulty with, and we needed to listen to them in order to make the project work. Building knowledge. As I mentioned before, several of the faculty have master's degrees in mathematics, but hadn't actually taken any statistics classes, or if they had a statistics class, it was only one. And so they had problems with some of the same content that our students have problems with. But of course, they're expected to teach these ideas. So having the ability to come to these course community meetings and ask, could you explain to me what a coefficient of determination really is anyway? That sort of thing really helped. And this was the biggest surprise to me personally, was how much time we spent in those meetings talking about the content of the course. And I'm so relieved that we did, because I think that the faculty felt so much more confident, and then that communicated itself to the students. Then we also did talk about pedagogy. We talked about active learning and different moves that you could use in the classroom to get your students to talk about statistics to each other. And then we had the statistical knowledge for teaching questions, which are more like, you have to understand this concept before you can understand that concept. So right before you start talking about the normal distribution, you're going to want to bring up again the empirical rule that we talked about 3 weeks ago. And then finally, we used a lot of the data that had been collected in this class to make decisions about the class. In particular, the class has a common final, but the data from the common final was not being analyzed. That is, each individual teacher got their grades for their class, and the overall average grade for everybody was sent out. But information about which particular questions people were having problems with was not given out to each faculty member. And now it is starting to be given out. The faculty were also asked to fill out self-surveys every 2 weeks throughout the course, and that allowed us to see where we were having particular issues with the implementation of the active learning. So then once the fall semester was done and we had created this community and become more of a team, then in the spring semester, oh, and I missed a slide. So at the course community meetings, we talked about different things like teacher moves that you can do in order to get students to be thinking instead of students offloading the thinking onto the professor. And we talked about which particular topics on the final exam a lot of people were having problems answering correctly. We also talked about what different activities were for teaching regression, for example, or teaching probability or that sort of thing. So the course community meetings had agendas each time, and it was important that we had a particular idea of what we would talk about, because we didn't want these meetings to become complainathons. We didn't want people to be just talking about how difficult it is to get their students to pay attention. We wanted to have solutions and not just a reiteration of problems. So in the spring semester, we implemented the change, and students and teachers both got different things that would help with this change. For the students, they were given a workbook, and in the workbook were 10 activities, in-class activities that addressed particular topics throughout the semester. So you can see there's a picture of people dropping a ball. That's the regression on the rebound activity. You drop a ball from a particular drop height and measure how high it rebounds, and do that for a bunch of different heights, and then create a regression equation that explains the relationship between the drop height and the rebound height. Each of these activities was paired with a video quiz activity that was done at home. So you'll see there's a video there of probability post-class activity. Those quizzes were a short 2 or 3 minute video, and then several questions, and then another short 2 or 3 minute video. And the second video answers the questions that the first video asked, so that there's immediate feedback. The purpose of those out-of-class video quizzes was to address the topics that we were not addressing in class because we were spending time gathering data from bouncing balls and that sort of thing. Several of the faculty were concerned that if they spent a lot of class time on these activities, then their students would get exposed to less statistics because they didn't have time to cover all of the other information. So the purpose of those out-of-class activities was to cover the stuff that was not covered in class because we were doing the activities. So in addition to the 10 activities, the days when activities didn't happen have short questions that we call warm-ups. They're very brief questions that allow you to continue the group discussion that we started with the activities, and the students talked to each other about statistics during that time. The teachers were given a teacher guide, and the teacher guide has, in black, the teachers see what the student guide has. The green is the answers to those questions, and the red is comments on how to teach those particular ideas. The teachers were also given videos of an experienced teacher teaching the activities that are in the student guide, so that if you're reading the description of the activity and you're not really sure how that's supposed to go, you can watch the video. And finally, we had a common course calendar where what is covered each day, what you need to bring into class, and what you need to assign for homework is set out for each day. Now, at MTSU, some of our classes are Tuesday, Thursday, and some of our classes are Monday, Wednesday, Friday. So the course calendar had to be a little bit flexible to allow for the difference between the 2-day-a-week and the 3-day-a-week classes. But that was not all that difficult to have two versions of the course calendar. After the change went through, then the question becomes, how do we maintain that change? And we have a website called mtstatpal.com. And on the website, teachers can go to the teacher page, which is password protected. It keeps students from being able to see the answers to things. And on that teacher page, they can see the student version of the activity, the teacher version of that activity, the video of that activity being done, and links to the quizzes. So it's all there in one place, and it's set up in a calendar format so that teachers can know exactly what they're supposed to do when. That makes it a little bit easier for new teachers to pick up. In the time that has followed the year that I was talking about, the course community has continued to meet, not as frequently. We're not meeting every 2 weeks anymore, but at least 3 times a semester. And during the year that we implemented this method, each of the teachers got a small stipend for participating in the course community, but that stipend has gone. We don't have that grant support anymore, and yet the teachers still show up to the course community meetings just because they find that it really helps. The fact that the course community is still meeting also helps to add new teachers to the course, because being an intro level course, we get a lot of people new start teaching that class, especially the graduate students. Graduate students tend to graduate, and when they graduate, then new graduate students come in. And so we need to have a way to train people very quickly on how we want this course taught. And then finally, supplies for the activities. Some of the activities have balls that are dropped, and some of them have candies, and some of them have paper towels and pitchers. All of those supplies are kept in a central location in the department office so that anyone can access them when they need to run that class. So I want to talk about the effect of this community on the teachers and on the students. And we had the teachers throughout the year keep a journal every 2 weeks about their experience with the class. And 3 of those teachers had never taught statistics before. And so those are the 3 that I'm focusing on here. If you look at their comments in August, you see, I'm scared, I've never taught statistics before, I'm worried about covering everything. Then if you look at December, from August to December, we've had the course community meet, but not the new materials and not the active learning part. And they're saying, I've increased in my knowledge, I've definitely grown. And then if you look from December to May, you're getting statements like, I feel competent, I know what I'm doing, I'm able to do this myself. In fact, one of these teachers helped us with the edit to the booklet and pretty much rewrote one of the activities for us. So that just shows how much she felt that she grew over the course of the project. Now, these comments are from teachers who started with nothing, but I think that even those of us who knew statistics before and had studied statistics education also got a lot out of the project, because we were exposed to the interest that people had in improving their skills. I was mentioning before the webinar started that one of the worries that I had when we started this project was that people would feel that we were stepping on their toes. They would be offended that we were going to tell them how to teach. And instead, we got reactions of gratitude, and people were just so happy to be helped in teaching this class well. And in fact, we've had comments about, so are you going to do this in this other class? We've got questions about pre-calculus now. So I think that the teachers in general got a lot out of this project. Of course, the question is, what did it do for students? These numbers are comparing to the average in the fall, and the average in the fall for the standard course on the final exam was 58.5%, and the average in the fall for the prescribed course on the final exam was 50.4%. Not great. We had a little bit of hard time deciding how to compare the course community members to the general population. And we decided that those of us who were part of the MTStatPal project who had written the workbook should not be included. So that's why the N for the standard course in the fall is so small, because most of the standard course students were being taught by faculty who wrote the MTStatPal materials. And so we didn't think it was fair to compare us to everybody else. So if you look at the spring numbers, you'll see, first of all, both of those averages are higher than the averages in the fall. And secondly, the difference between the standard course and the prescribed course has gone away. There is no statistically significant difference between the averages for the standard course and the averages for the prescribed course. What I'm finding here, and what has been shown in other papers, is that active learning is a big help to the people who are the least prepared, and is a smaller help to the people who are well prepared. So that's not all that surprising, but it's really beneficial to see that big jump. Obviously, we would like to get those averages up another grade point, or another 10 points at least, but at least we're going in the right direction. I should mention that because we made so many changes, it's hard to identify exactly which changes are responsible for the changes in these averages. Part of the difference between fall and spring is that the teachers in the fall had never taught statistics before. Many of them had, but many of them had not. And in the spring, because of support from the department chairs and the dean, we were able to keep the same people teaching. And that meant that they had more experience with the class in the spring. Also in the spring, we had the active learning materials. So it's hard to disentangle how much of that improvement is experienced by the faculty member and how much of that improvement is the materials. But what we are seeing is that that improvement did happen. And if the improvement was due to the materials, I would argue that we would not have seen that improvement due to the materials if we had not done the course community first. Because having done the course community first, we convinced the faculty members that this is a good thing to do and that these methods of teaching are supported by evidence. And therefore, they were a little bit more likely to implement the materials in a more faithful way, where when we were first testing them, we found a lot of people using our active lesson as an outline for a lecture instead of giving the students the opportunity to do the activity. So the references, the first one is the article that we wrote about this, and it has a lot more detail about this project. And then these other ones are articles that I quoted through the presentation. So I'd like to thank you for taking the time to listen to me and ask if anybody has any questions.
Well, thank you, Lisa, for this presentation. And we did have a question come in the middle. Someone said, some senior faculty want to teach this class so that students can become good researchers, and hence they do not want to follow a calendar of topics given to them. What do we do in that case? So I know you mentioned that you didn't see as much resistance as you thought, but did you deal with a lot of senior faculty in this project, or was it more like teaching faculty that were involved with it?
The senior faculty that we dealt with tended to be people who were part of our project to begin with, but we did have one faculty member who was of the opinion that he did not need to change his teaching methods, and he didn't that year. And the next year he didn't. But because we were now advertising the details about the final exam, he started noticing that everybody else's final exam scores were going up and his were staying the same. And so he still doesn't completely follow the entire workbook, but he uses a lot of the materials, a lot more than he did when we were first starting. So I think part of it is convincing people that it works. You know, you have to give them the reasoning behind why you're choosing this particular method to teach this class. And part of it is allowing them to change the materials if they want to. Our materials are very flexible, and we have the bookstore print them, and the students pay just the cost of the copying. So we can easily change the workbook if we find a particular lesson needs updating or rewording or something like that. So we gave him the opportunity to modify a lesson. And his edits actually did make a valuable difference. So I think part of it is just taking everybody's input and using it. It gives the people who had the input buy-in into the entire project.
That's interesting. And just by the way, if any of you have questions that you want to ask Dr. Green, please go ahead and type them into the questions box. John asks, how did client disciplines react?
We actually haven't had a lot of comments one way or the other from our client disciplines. I did present something about this to the teaching and learning community here on campus, and people were fairly surprised to hear about it. So that tells me that their students aren't really talking to them about what they're learning in statistics.
All right. I'm trying to think if I had any more questions for you. I guess my question is this information that you've got in your workbook and you give us the link to it, is this something that you're all right with other people taking and using? That's the
Absolutely.
Shani's question. I'm not sure I'm saying the
Absolutely.
right.
The development of the workbook was supported by the NSF, and we would love for people to use it. And what I would encourage you to do if you want to use it is don't use them exactly the way we have them written. Work together with a group of people in your department that teach this class and decide on which things you'd like to keep the way we have them and which things you'd like to tweak a little bit. Because the buy-in from the faculty is what's going to make this work. And if you just deliver a finished product to them, you're not going to get that buy-in.
So you recommend that we take it as like a template and make it more homegrown in our own institutions.
Exactly.
Okay.
And we do have a regular textbook. We teach from the Sullivan textbook. And so the workbook this is the stuff that you do in class. It's not a replacement for a textbook.
Okay. Another question, are you seeing students move to these sections that are using the learning community faculty, or do you actually have everybody teaching it?
At the beginning, we didn't have everybody teaching from this method, but now it is everybody.
So the question about where can we preview the workbook, I think I wrote it down, the mtstatpal.com.
Yes.
Is that the place? Maybe you can scroll back to that.
I had originally planned to click on this, but then I was worried that it wasn't going to show up. So let's see if I can do that.
While you're doing that, Lisa, they're asking if you could repeat what you said about some faculty use the course calendar as an outline for a lecture instead of allowing students to do the activities. And I think you were saying that some people are using the activities as their lecture rather than letting students do them.
Right. So if we look, I've got the website up right now, and the very first lesson that we do in class is helper hinderer. And you may know this activity because this is something that has been published by Rossman, Chance, and Holcomb. And so it's one that people pretty much know. But if you look at it, it's got a lot of questions that students are supposed to talk to each other about and then answer. And when we were first doing our tests of this entire workbook, we found that teachers would default to standing in front and asking the entire class question 1 and then answering question 1 himself, and then asking the entire class question 2 and then answering question 2, instead of allowing the students to work in groups and struggle with this information themselves.
I have TAs that do that.
Yeah.
Yeah. And then I guess maybe we have time for one more question. Which of these ancillary materials did your faculties find the most useful, and have you seen any that have not been as useful as the others?
If you look over here at the warm-ups, these are short questions that people ask at the beginning of a class where they don't have an activity. They're going to give their own lesson. And the idea is this is a very quick question that people are going to answer very quickly, and then you'll go on and do your own lesson. We've had several faculty members just skip the warm-ups altogether. And in general, they end up regretting it. The warm-ups were chosen to be in those particular locations because they're refreshing a memory of a previous lesson just before you teach the idea that that particular lesson covers. So for example, the empirical rule warm-up is right when you're going to be talking about properties of the normal distribution. And the other thing that we chose those warm-ups to do was to address those questions that people tended to get wrong on the final exam. So there's a warm-up, can't find it right now, but there's a warm-up about probability. What should the probability of this be so that it's a probability distribution? That's a question that people tended to get wrong on the final exam, and it's enough after the probability chapter that they don't remember. And so having that refreshing of that idea helps them when it's time to study for the final exam.
All right. Well, thank you for this presentation and also for making this available for the rest of us to maybe incorporate in our own culture changes that we're trying to make where we are. And thank you all for attending. We do have more upcoming webinars in the months ahead. So I hope you'll keep an eye on that. And thanks again, Lisa, for this great presentation.
Great. Thank you.
Goodbye.
Bye.